Good afternoon, Year 5. Welcome back. So we're going to dive straight into our science lesson. So today we're continuing on our unit of Earth and its place in space that we've been looking at. Now, today our learning outcome is going to be a little different. So today we're learning to develop scientific explanations about the Earth and space using our observations and learning experiences. So basically what that means is developing scientific explanations is we're learning to talk about what we've learnt in ways that we can explain things to other people to share our knowledge of what we've learnt. All right, so what we're going to do first is we're going to go through and review our points on Galileo that we've got here. So we did this during our research English time. We looked at Galileo and a few different sources, and we found that Galileo was one of the first people to provide evidence to support the sun being the centre of the solar system. He built powerful telescopes that let us see Jupiter and its 4 moons. He was able to see 4 of Jupiter's moons orbiting around. He made many more telescopes and observed other space objects and their movements. And the sun-centered solar system model was accepted as more observations were made by others. So basically, they took his observations, other people then built on them, and that's what led for it to be a model that was accepted scientifically. He built telescopes that magnified things up to 20 times, and he drew the moon's faces as seen through the telescope, showing that the moon's surface was not smooth. Because up until Galileo, looking at the moon, you see it from where we are and it looks very smooth and shiny. But he actually, using his telescopes, found out that it was not smooth at all. So what Galileo did was he used his observations and his learning experiences to develop scientific explanations about positions and movements of the sun, the earth, the moon, and some other objects within our solar system. So that's what we're going to be doing today. So we're going to go through some questions. Now you each made your own individual orrery at the beginning of our unit. Now because these were made at the beginning of our unit before we'd even gotten into any of our learning, what we've done is, what we're going to do is reflect on them individually, but we're going to be in our table groups so that we can discuss what we're thinking with our partners, with our mates at our table, and that way we've got a better understanding. If we're not quite sure about something, maybe someone else at our table might know, and that can give us a bit of a helping hand. So you're going to go away with your orreries, and I want you to think about, I want you to be able to explain your orrery's movement, so how it moves, and whether or not this still reflects what you think. So thinking about our observations and learning experiences, do you still think that this is the way that the sun, the earth, and the moon are placed in our solar system, that that's their relative distances, things like that? So I'm going to give you 5 minutes to go away, have a little look, have a think, and have a table talk. Fantastic. So I did see quite a few of you at your tables discussing using your scientific terms like orbit and rotation. So Marcy, would you be able to, I'm going to hold your orrery up here, would you be able to explain to us your orrery and how it moves? Okay, so the Earth's in the center of the solar system, and we've got the sun and the moon, and they orbit. Which way? Which way do you want it to move? Clockwise. All right, so you think that it goes around like this. That's the way you built it at the beginning. Okay, now can you tell me, does this still reflect what you think? No. Oh, it doesn't. Why is that? Okay, yeah, so because we've learned that the sun is the center of our solar system. So you don't actually think it works this way anymore. Okay, well don't worry, there'll be time to do revisions later. Fantastic. So then we're going to look at something else. We're going to do the same thing as before. You're going to look at your individual orrery, but we're going to be in our table groups that you can discuss. How does your orrery represent the movements in space that mark a day, a month, and a year? So I noticed, Marcus, that even though you've got the sun out here, you think that you can still get your orrery to do a day, a month, and a year. So why don't you take that back to your table with you? Have a look, have a talk to your peers, and see what you can come up with. I'm going to give you another 5 to 10 minutes. I'll walk around and see how we're going. Fantastic. All right, guys. So, can you explain to me, sorry, I'm going to pick on you again. It's okay, though. How it is that you think that your orrery can show a day? Because the Earth rotates anti-clockwise. Okay. Well, your Earth does rotate. Very well done. So our Earth rotates anti-clockwise, and that is how we get our day and night. I can see that could work. Yeah, okay. And a month. How do we get a month? That is correct. Yes, exactly, Marcy. So the moon orbits around the Earth, and that's how we get our month. Okay, so I can see how you think that that works. The moon is orbiting around. The sun is shining light, so we can still see our phases of the moon. But what about a year? How do we get a year? Yes, Jacob. That is correct. Now, Marcus, do you still think you can get a year out of this? Because I don't think that the Earth can orbit the sun when it's in the center. It doesn't look quite right. So what we can do is, again, things to think about for when we go back and review our orreries and fix them up. And I want you to now, using your science journals, using our observations and learning experiences, what changes would you like to make to your model? So you're each going to take a turn standing up at your table, and you're going to explain to the others at your table what things you'd like to change and what things you think should stay the same on your orreries. Then we're going to have a chance to revamp them, remake them if you need to. If you want to start from scratch, you can, there's enough time. And we will look at our final product and see if if we all come up with the same or if we still think different things. All right. So what I really liked then when you guys were standing up and talking to each other is the way that you were saying orbits. So you were talking about how Earth orbits the sun. That was really great. I liked your language when you talked about Earth's rotation and when you talked about the moon. So I had one group over here talking about how the moon waxed and waned when it went around. So if I could get you to stand up and your speaker of your group, if you could just explain to the group, I'll hold the diagram up here, if you could explain to the group what you mean when you were talking about the moon phases and waxing and waning. Okay, so where do you want the moon to start? The very top? Okay. So that would be a full moon, that's right. So we can see that the sun's light is projecting onto a full half side of the moon. So that to us looks like a circle. So we don't have a full moon up here, but we see a circular shape as the moon to us. So a full moon is when we see the light over the full moon, which is what we would have here. All right, so then which way am I going to turn the moon? Anti-clockwise. So is that this way? No, I've got it wrong. Oh, is it this way? Ah, okay. So we're going to turn it. And as we're turning it, we can see that the light is going to be reflecting not from the whole moon anymore. It will only be from a slice of the moon. Ah, and is the slice getting bigger or smaller? Smaller. And what's that called? Waning. Okay, so the moon's waning as it comes around. All right, so what happens when the sun, see the sun is still shining on half of the moon though. So why are you telling me we wouldn't be able to see it? Because we on Earth can only see the dark side of the moon, which means we can't really see it at all. Fantastic. So then we go around and we start coming onto the new moons as we come around. All right. So what were you saying as the moon's coming back around to full moon again? It's waxing. So waxing means that it's getting bigger. That's right. So this really goes to show that because the moon is spherical and it reflects the light of the sun, that's how we get our phases of the moon as we're going through. Fantastic. Now I did hear a lot of you standing up and talking about your orreries and discussing them and how they moved. I liked how all of you had the sun as the center of the solar system and how you had the Earth orbiting. What happens once the Earth makes a full orbit? What is that? What passage of time does that mark? A year, yes, that's correct. It marks a year. Well done. All right, fantastic. So, looking back at our learning outcome, so we were developing scientific explanations about the Earth and space using our observation and learning experiences. Do you think we met this goal? Lauren? Yes, we did. All right, do you want to explain to us how we've met this goal? Fantastic, yeah, we used our ORIs. We found out that what we initially thought wasn't correct, so we used our observations and our learning experiences to create an ORI that matched with our observations, that matched with the scientific explanations, and then you all stood up and you all told us about your ORI and how it works. That's absolutely fantastic. I think we nailed our learning goal and you guys have done great. So next lesson, we're going into the solar system and extending out to view the other planets and satellites within the solar system. Thank you.